Hey everybody, how you doing? Welcome to a new video of Amazing Mac stuff. Do you like my new mustache? I kind of like it. I still have to decide how to say. For the moment, I will rock it. Anyway, this is the patch as we left it last time, and in this video, I would like to kind of animate our shape. So basically, what we got here is our camera, which we can move using the WASD, Q, Z keys, and then we have the shape, and we have the floor, and we have a light that is illuminating our scene. Now, our shapes have a GGL material attached to make it look a bit better, to make the reflections look a bit cooler. Now, one word about the light. So the light is up here. Let's actually encapsulate it too. So light, also with the grid shape that kind of represents it. And to encapsulate, again, Command plus Shift plus E. So one word about the light. By default, the light has a type. So if we go into the type attribute of the light using the attribute object, this I remind you, this is the attribute object, you can see that by default is set to directional. For example, we could use something like point light, which is kind of if the light goes in all directions, like if the light is a point. And then we have spot, which kind of makes like a spot light, so it illuminates only one part of the image. I kind of like the point light, I find it pretty cool. So let's actually hard code this attribute into the light. Let's write type point. Of course, depends on what you want to do with the light, but I find that the point gives especially interesting reflections in this case. As you can see, the back of the sphere is completely dark because there is no ambient lighting. So we could actually fix this by setting the ambient light of the light, so the ambient attribute of the light object, to something like a bit gray. This means that also the parts that are completely in the darkness will be illuminated. Will be actually not completely dark, but kind of, yeah, like this. The color that we set for the light, for the ambient. If I would make this red, then everything would have been a bit red. This is actually a number that gets added to the color of your shape, so this will kind of make an offset on the color. It could be something that you want to have, like something that you don't want to have. Actually, I have to say, now that I've done it, I don't really like it, so let's actually get it back to 0. And let's maybe make the background also a bit darker. So I will create just a grayish background. This looks kind of cooler. And at least it makes sense that what is not on the light is on the shadows. Okay, so we have a point light now, and as I said, let's start to animate a bit the scene. So first of all, let's animate our sphere here. So let's keep the handle here. Let's encapsulate this shape. So this will be the sphere. Go inside the sphere subpatch, and we have our sphere. Now let's say that I want our sphere to move in circle, and I don't want to use my mouse to do this. I want that she does this automatically. We will do this by using a cosine and sine in order to create like a circle, the formula for a circle, so that the sphere will just move in a circle on the XY plane. On the XZ plane, sorry. So let's do this. Let's create a cosine. I give it at 0 but actually there is no, I'm setting at 0 into this object, but actually I think there is no need, because it will anyway give us a floating point operation. Let me see, yeah. So we actually don't need to set the 0 here. Okay. So basically, we want to use the same number for the cosine and the sine, and we want to set these as the position of this object, so on the x and the y position of this the x and the zeta position of the object. So I will attach it to the second input, which represents this 0 here, which is the x position, and this will attach to the z, to the last input, which is the z position. Then I attach this to the GGL grid shape object. Let's move this a bit here. And let's see. Okay, so now the sphere is moving in a little circle. The sphere is moving in a little circle around the center. Now let's say that we want this circle to be bigger. We just have to multiply the cosine and the sine for some number. For example, 5. This will be the radius of the circle. So the circle in which the sphere moves. So that's it. So the sphere is now moving in a radius of 5. Okay, let's now say that we want this to be automatized. How can we do that? It's very easy. We will just create a counter, and we will say, create a counter and say, okay, let's divide this by something like 100. And this will be automatically updated using a bang. So we have to get a bang. Now the central output of JIT gives us a bang for every frame that it renders. So it's actually like a metro. So it's the perfect bang to use to animate stuff in our patch. So I will create a sender and say send metro. I will copy it, go inside sphere, and here let's put everything a bit down, and I will create a receiver for this. So receive metro, boom. And as you can see, the sphere now moves automatically. We can still go around with the camera. Now it looks fairly okay. Let's maybe reduce the size of the radius a bit here. And yeah, it's a sphere that is moving on a circle on the XZ plane. Let's actually move like our light in the center of the scene, because by default it's at 1, 1, 1. So let's actually move it to the center, and let's move it also the grid shape that kind of represents it to the center. Okay, cool. So this is now some kind of sun, and we have a little planet orbiting around it, and somehow there is also a floor for some reason. Anyway, oh, this is still the, when I click here, you can see still the handle that is connected to the sphere. So let's actually disable it by setting enable 0 to the GGL handle which is attached to the sphere. So inside the sphere sub patch, enable 0. Okay. Okay, cool. We could, of course, make it also move on the Y axis, but without going below 0, maybe. So let's do like this. Let's create, I don't know, something like another cosine. Let's attach this here. And let's add 1 to it. So now the range is between 0 and 2. And let's try to use it as it is. Okay. So as we can see, the sphere is going up and down. Let's actually make this a bit faster. So we can multiply this by 2. So this will go a bit faster. As you can see, it goes up, then it goes down, goes up and down. Yeah, this kind of stuff. So pretty easy. And this is how we can animate a shape. You know what? Let's actually copy this wall subpatch, and we have now another sphere. Now we will see in the future how to create multiple objects in a faster way, but for the moment I just want a couple of them, because I want to show you another way to actually animate our objects. So let's do like this. Let's actually encapsulate all the positions algorithm. So we'll encapsulate, I'm inside the second sphere. So I encapsulate the position algorithm. So let's actually call this sphere 2. Go inside, this is encapsulated. I go inside the subpatch with the position algorithm. And let's do like this. Let's delete this because I want to show you another way in which we can animate the movement of this shape. We will do this by using a jit.bfg object. So this object gives us a matrix containing some kind of noise. So there are several noise, and we will use one of those noise. So first of all, it needs 3 planes, float 32, which is the type. We want the numbers to be in the float 32 range, so around 0 and 1. And then we want just we want a dimension of 2, 2, and 1. Now 2 is the x dimension of this matrix, this other 2 is the y dimension, this 1 is actually the z dimension of this matrix, which is actually one single cell. So why do I write it? Because this will be useful when we want to offset this matrix along the zeta axis. So let's actually take, first we have also to write the basis that we want to use. I will use noise simplex. So let's see what this gives us. Let's create a JitP window. I will attach this here with a bang. We can see what this object will give us. So if I bang, it gives us some random numbers according to a certain formula, which is the noise simplex. Let's say I use more cells. We will see a better, yeah, this is how actually the noise looks like. So as you can see, it's kind of a continuously gradually variation of random numbers. But we don't need so many cells because we just need 3 numbers for the 3 axes. So we actually could also use only 1 cell, but in this way GBFG doesn't work, so it needs at least 2 cells for the x and the y dimension. So, okay, what we need to do is now to create an offset, so the offset attribute for the JitBFG, but only on the 3rd dimension, only on the zeta dimension. So let's see how this looks like. Oh, and let's also say bang. So once you create the offset, then bang the matrix out. Let's see how it looks with more cells. It looks like this. We are basically traveling through the function, kind of, how you can say, perpendicular to the screen. So we're going inside the function in this way. It's kind of interesting. So we anyway need, as we say, we need only 2 by 2. Perfect. Let's use the metro actually, and again another counter to have a continuously. Let's divide this by 200. To have a continuous offset, which will give us a matrix, which we can use then to move the shape in the space. So let's use jit.iter to transform this matrix into a list. So let's see. I think this actually gives us actually 2 lists, for 1 for every cell. Now it gives us 4 lists for all the cells of the matrix. So 2 for the x and 2 for the y. We actually just need 1 of these lists. So let's actually use a jit submatrix first. So jit.submatrix, and let's set the dimension to 1. So we get only 1 single dimension of this matrix. Let's see if this worked. Yeah, okay, perfect. So this is what we need. And oh, cool, we can just attach this actually here to the second input, and it will redistribute the numbers or all the other inputs, or we can actually just write prepend position. It's kind of the more neat way to do that. So let's do like this. This will prepend the word position to this list. So let's attach the offset here. Okay. And as you can see, the sphere is moving in a random way. So it's moving according to the noise. As you can see, it's kind of biased, this noise, because it doesn't really go between -1 and 1. So what we want to do is to use, if you go inside the help of JIT-BFG, you can see there is something called prepend setat basis. Let's go actually, prepend setat basis and then sign. Sign maps the output to -1 to 1 for float 32 to float 64 matrix type. So this is exactly what we need. We need to map this output to float to -1 to 1. So let's write setup prepend setat basis, and then let's write sign 1, and let's give it a load bang. Oops, I wrote load bang how I pronounced it. Okay, so let's click on it, and now it goes -1 to 1, but as you can see, it goes -1 to 1, which is actually not exactly what we want, because then it goes below 1. So what we can do is to sum 1 to this matrix. So let's do it with a jit.op, and then we have to write which kind of operator we want, and then the value we want to sum, which is 1. So this is a jit.op, just sums 1 to the incoming matrix. So as you can see now, the sphere, oh, it still goes below 0. Why? So let's sum 2. Let's see which kind of list we get here. We still get negative numbers. Oh yeah, because it actually they go quite up, those numbers. So let's back to sum 1, and then let's do like this. Let's use a jit.clip. I never used this object actually. Let me see how it works. Okay, we have to set a minimum and a maximum. So our minimum will be 0.2. Our maximum will be 3. So our shape will move now in all the axes between 0.2 and 3. So let's see. Yeah, as you can see, it works. Let's set the higher maximum to 6. Okay. Oh. But this will actually... This will actually prevent it to go in the minimum axis on the X and the Z axis, which is actually something that we want. So let's actually delete this GPU window, and let's first unpack this matrix. Git unpack. We want to unpack this matrix first, apply the clipping only to the Y axis, and then let's pack again. So like with unpack and pack, but this time we do it with the matrices. So exactly like that. So now it should be okay. Yeah, seems to work. So the sphere is moving around. It doesn't go below 0.2 on the Y axis, but otherwise it moves fairly randomly around in this simple world. Okay, you know what? I kind of like this algorithm that we created. Let's copy it and apply it also to the light. So let's copy it inside the light subpatch and attach it both to the GGL light and to the GGL grid shape. So now our light will move randomly around in the world, illuminating the shapes. Let's go inside sphere 2 and give it actually a diffuse color to the GGL. Since we are not using a texture, let's actually give it a color to the sphere using math diffuse, and then let's make it, for example, red. Okay, so now this sphere is red. Let's go actually into the previous one, and let's give it also a color using matte, the attribute matte diffuse, and then blue, for example. No, let's say green, because we already have blue. Okay, so that's it. Yeah, so let's actually pack this little algorithm too, and we will call this position circle. Cool. And sphere 2, let's call this position noise. Okay. So we have seen a couple of ways in which we can animate our objects in the scene. As you can see, sometimes they collide to each other, they just compenetrate, which is something that we maybe don't want. We will see how to avoid this in the future by using the physical library of Max. But for the moment, let's say that this is it. So let's actually stop with this video again, and I'm sorry for uploading this so with such a great interval between each video, but I got kind of busy. I mean, everybody's busy. So yeah, I will try to upload the next one sooner. Anyway, thank you for following. Of course, you can visit my Patreon to first download the patch, and second, you can even consider to support me, which will give you access to a lot of patches, and also to my Discord channel, in which you can talk with me, you can ask me stuff. There is already actually a lot of people, which makes me super happy about the Discord community, which is growing every day, so yeah, feel free to join, this would be great. Anyway, thank you for following again, and see you in the next video. Ciao!